Hello, Dhanesh sir, am I audible?
Sir, you are audible.
Yes, sir. Yes, sir.
Okay.
You are audible.
So,
Continue.
good morning, everyone. Myself, Dr. Chandan Kumar, Associate Professor, Mechanical Engineering Department, BIT Sindri, and coordinator of this Meet 2021. Once again, I welcome all of you in the second day of technical session. Dear participants, you have attended the very nice, wonderful lecture given by Mr. Engineer Raj Kumar yesterday. Today, once again, Mr. Raj Kumar is going to deliver a lecture based on 3D printing and reverse engineering. He will cover reverse engineering also today. So today lecture will be once again going to be very informative and interactive. I would like to read or introduce the speaker, Engineer Raj Kumar. Engineer Raj Kumar is Application Manager at Adroitic Information System Private Limited, Noida. He is having 11 plus years experience in industry as well as academics. Currently serving as an application manager. Currently application manager additive manufacturing in AM division called 4D simulations at Adroitic. Adroitic is a fast growing, having its presence in the entire country, contributed a lot in the field of design and additive manufacturing, developed various industrial as well as medical applications with the additive manufacturing. He contributed to other relevant technologies like reverse engineering, vacuum casting, tool making, etc. He has served as an assistant professor in the Department of Mechanical Engineering at Noida Institute of Engineering Technology, NIT, Greater Noida. This institute is in NIRF ranking. Department is NBA accredited for 7 years and many other um, achievements is having with NIET. He was the part of innovation labs and ICC cells of NIT and always contributed for innovation to improve social life as well as for social welfare for what he was committed. He is a pipeline engineer in a pipeline projects of Trans Canada Pipeline with Applause RTD quality service, having the few patents under his name in medical as well as consumer goods, having international publication in Scopus and SCI. His highest qualification is Master of Technology in Mechanical Engineering. He loves design new products and taking additive manufacturing as a passion. Apart from this, I would like to mention that uh, uh, I feel very proud as I have worked with him for few years with him. So now I will request Engineer Raj Kumar. I personally welcome you in this FDP and I request you to deliver your wonderful talk in this session. Thank you everyone for joining the FDP. I wish a very good learning in this session. So Raj Kumar, please.
Thank you so much, sir. Good morning, all of you. I don't know how to express this gratitude. So I'm start sharing my screen. So yesterday we left here at the SLS. So selective laser sintering was the last process we discussed. So moving further, in order to continue the same slide. So next technology is based on the same kind of technology, you can say, same kind of classification. This classification is based on this powder-based additive manufacturing system. So in powder-based additive manufacturing system, there is one more technology which is there is vendor jetting technology. So this is a very unique technology, you can say. Actually, there is no laser light is required in order to do the 3D printing. Instead of using the laser in this particular technology, we use binder as a material of forming the powder material. So the powder material can be joined with the help of binder, and that binder nozzle can be transmitted with the help of mechanical apparatuses like stepper motor and gantries. So this thing happens with the help of a nozzle, or you can say multiple nozzles as well, as you must have seen through the polyjet technology. So in polyjet technology, the material was coming out from the nozzles, but here the binder will be coming out from the nozzles, and the powder will be deposited over the build platform layer by layer with the help of roller, which was the process of SLS. So in SLS, the sintering operation was happening with the help of laser, but here the binding operation is happening through the nozzles, or you can say a single nozzle or the multiple nozzle. So this technology is having great advantages with us. So with this particular technology, we can do the indirect metal 3D printing. We can do ceramic 3D printing. We can do various 3D printings with the help of this particular technology. So there is very less limitations of material. So we can use almost every material which is existing in 3D printing. So we can go with this particular technology. So this is the basic advantage of this particular technology. So in order to do the printing in metals, we can go with a process which is known as metal injection molding process. The process remains same. So we need a separate sinter in order to do the like a centering operation for the part. So that particular machine can create a green part. That green part can further go to the center, and before going to the center, it must have some wash operation as well, so that the binder can be actually that process is known as debinding process, that we like generally call it a wash operation, that debinding operation. Then after that debinding operation, we can send the part into the center. Then it can be shrink at a certain ratio according to the material properties and the heat treatment properties. So this particular process involve this process, this metal printing operation. Apart from that, there are several materials we can use on this, like ceramic. So sculpture applications can be addressed through this, and few more ceramic printing operations can also be addressed. So this particular technology is having one more advantage with us. We can build a large volume component out of it. So there are like huge machines as well, the smaller machines as well. So this is a very unique technology. So let me show you a video so that it will be more clear to you. So there is basically a deposition of material. The thing which you can see through the white color, that is the material deposited. That may be a ceramic, that may be a kind of like plastic, you can say. And this is a head which is having a multiple nozzles. According to the sliced data, on the basis of that sliced data, the deposition occurs here. So after every deposition, the head moves towards the cleaner. So it get clean, because head may have some deposition of powder material that may block the nozzles of the head. That is why the cleaning operation is also important with each and every deposition. So this is the particular process which is going on layer by layer. So this particular thing is happening, like this particular binder is a photopolymer again. So this photopolymerization process requires a curing operation. So curing operation can be done through this particular thing. So this will be having a fusing lamps over here. So it is not always necessary that the binding material would be a photopolymer. That may be some other polymer as well. Some epoxies may be there, and all different epoxies has the different properties. Some epoxies may have the properties to cure with the help of your laser light, cure maybe with the help of some UV lamps, cure maybe with the help of some fusing lamps, cure maybe with the help of some heating operation. or with the help of some blower operation. So that would be totally dependent over the OEM who is producing the this particular machine, and what is the working principle of that particular machine. But the basic principle remains same.
सेम तुम अलाउ नहीं कर रहे हो, करो ना बे।
All the other advantages of this particular technology remain same as you are having in SLS, like there is no support structure required, all those things are there. And there are some limitations as well. Those limitations are this will have some multiple exercises to do in order to get the metal printing outputs. And in some cases the agents which are there, those agents may not be completely wiped out, so it may create some porosity during the sintering operation. So there are some issues related to the machine, but in most of the applications it may fit well. So next technology is in the category of solid-based additive manufacturing system, which is known as laminated object manufacturing. So laminated object manufacturing is a technology which is additive just because of its one definition to deposit in the form of layers, but uh, it is also considered to be a subtractive manufacturing as well, because there is a lot of material waste and we have to remove the material. You would be able to understand the thing with the help of a couple of videos which I am having related to this particular technology. So here you are having a laser light, or you may have a cutter instead of this particular laser light. So in this particular image you can consider it as a laser light as a cutting tool. So that cutting tool may be laser, that cutting tool may be a knife. So with the help of this particular laser light, the cutting operation is happening through this particular sheet which is rolling through the machine. So this is rolling from this direction to this direction. So this rolling operation happens to be at this particular point, and this particular heated roller sticks the successive layers from this particular base. So if you look at this particular image, you will find the bit platform is moving downward, and this operation is happening with the help of rolling motion of this. So every new sheet of material will come up here, and with the help of this roller it will adhere to this particular surface, and in this particular surface, or with the help of this laser light, it cuts the surfaces according to the requirement or according to the counters which are there with us in the form of slicer file, or we can say a G code file. So on the basis of those cutting operations, it identifies the component, and accordingly successively layer by layer deposition happens with the help of this roller and this particular roll of film. So this may be a material, may be a plastic, that material may be a paper. So those rolls of paper or plastic put it over here, and that the used roll and paper, the waste take out, can be put it over here. And in this way the production of component takes place. So it will be more clear through this particular video. if you look at this part, this is having a gantry which is mounted over here, a laser, and this is a heated roller which will be helping it to adhere here with the like you can say successive layers, or you can say for the very first layer with the build platform. And this is a roll, and this is a consumed roll. So here if you look at this particular block, so this is a same block which we have considered through the machining operation. So these all parts, these all small segments are taking out are a complete waste. That is why it is also considered to a subtractive manufacturing. So so this is how the part gets built with this particular technology. We are having one more video with us, so you can see this. So this is actually the actual machine, which is not the animation. So you can go through this, and I think you would enjoy it.
Solidu presents its 3D desktop printer. Introducing the SD300, the world's first 3D desktop printer. With its compact size and unprecedented cost effectiveness, this breakthrough product is making 3D printing available to any office. From concept modeling to final product. Save time and money with the SD300. Now go from concept to final product without using a service bureau, thus reducing costs and time to market. The SD300, revolutionizing the way designers and engineers approach 3D modeling. Plug-and-play desktop installation. With the SD300, operation is made simple using the user-friendly instruction manual provided with the material kit. Install in a matter of minutes. First, insert the engineered plastic roll into the printer. The engineered plastic roll used in the SD300 is both durable and economical, giving you attractive build cost per model. Second, insert the glue cartridge. Third, insert the anti-glue cassette. Finally, place the 3 anti-glue pens. Now just hit the build button on the provided SD View software and your printer is off. Finally, a 3D printer you can afford. The model is created by layers of engineered plastic. Following sheet lamination, the cutting knife goes to work directly from your CAD data. The engineered plastic roll is layered using special glue, resulting in strong yet flexible models. The anti-glue pens then apply masking fluid for easy support removals, allowing even the smallest details to be created. Reducing development costs and time to market. Models are designed down to the smallest detail, and the engineered plastic roll is available in transparent or opaque colors. You now have your finished model in hand, ready for evaluation. without ever leaving the office. Multiple applications. The models produced by the SP300 are so detailed and accurate that they are perfectly suitable for all stages of production, including rapid manufacturing. They can be machined, drilled, finished, joined together, and painted. Larger models can be created as well, assembling one model or multiple models to each other. And all of this while showing no distortion over time.
मेरे दोस्त जिंदगी में कभी इस चोर की तरह
there is a disturbance. So next technology, which is also again based on the solid-based additive manufacturing system. In solid-based additive manufacturing system, here the material would be in the form of wire. Earlier you have seen the material is in the form of monomer, which was a liquid. There was a material in the form of powder, powder of metal, or you can say powder of plastic, and then you find a material with the in the form of sheet. But here the material is in the form of wire. So in this particular technology, there is a very simple process, and this is the most common 3D printing technology and most commonly available through the industries, through the academics, through the every field you can say. So in this particular technology, the principle is very simple. It is the normal extrusion process. So in this particular process, you are having a working material in the form of wire that is guided with the help of a feeder mechanism. That feeder mechanism could be having a gear inside it and a roller inside it. So that gear can be governed with the help of a stepper motor. That stepper motor extrudes or you can say eject or retract the material according to the G code which we can give to the software slicing. So this extrusion and the retraction is taken place with the help of this gear motion, and this roller will help to apply some pressure over it so that it would be having a proper grip with the gear. So with the help of this extrusion process, there is another setup which is over here, which is denoted by the 3. So this particular portion is the hot portion, which is known as the extruder. So this is a feeder assembly and this is the extruder assembly. The whole assembly can together be considered as the extruder assembly, because in general we know it as the extruder assembly, but there are certain cases like this particular case is having the whole the assembly combined together, but there are certain machines and the certain like you can say mechanism where the feeder mechanism is placed separately near to the screw here somewhere, and the extruder is just placed over the rods and the or the gantries you can say. This is just because in some cases what will happen, the fast motions can be avoided with this huge assembly. So this huge assembly can have the very higher weight. That weight may create the vibrations in the machine. So that will be totally depend on the gantry size and the size of the machine. So in a smaller machine, you would find the extruder would be placed over here on the head in order to make it light. But in case of the larger volume machine, in those machines you will find the whole assembly together. So this is something which is having a difference among in the different mechanism machine. So in this particular machine, this machine is known as the direct drive machine, and one machine which is having the extruder assembly separately and the feeder assembly separately, that mechanism is known as board and tube mechanism. So there are two mechanisms over here. So that will be totally dependent on the like your applications, on the basis of your sizes, on the basis of the material used. Because it has also been found that there are some flexible materials as well, which comes in the form of wire. Those flexible materials cannot be extruded with the help of board and tube mechanism, because material has to travel from this portion. If this particular unit is placed over here, if it is traveling from this portion to this portion, and it will bend in between on the way. So it will not be effectively cannot be extruded. So this is why in flexible material cases, or in case of the larger volume, it is there to be have a single assembly along with the extruder as well as the feeder. So in this particular technology, a nozzle is there. Nozzle deposits the material layer by layer in such a way. The nozzle may have the various sizes. The standard size of the nozzle may be 0.4 mm, and it may varies from 0.25 mm for plastics to 6 mm, you can say. So on the basis of that, the material diameter will also change. For a standard nozzle dia 0.4, the standard material dia is 1.75 mm. That may varies up to 6 mm. So this thing is there with the technology. So this particular portion is known as a build platform. That build platform may be the heated type or may be the cold type. So the heated type platform is required for those materials who are having the capability of cooling at the faster rate. And there are some challenges in the cooling of faster rate. Those challenges are like it may have some you can say some warpage issue, you can say, because plastic is insulator material. So in plastic, if the material variation is there throughout the component, if your component is get built and there is some like temperature variation, then it may have some tendency to cool down from the outer surface, and it will remain more in molten form from the inner surface. So uh, that may lead to the warpage issue, because the outer part may get shrink and the inner part may not get shrink. In this way, the distortion may happen. So this is why this particular build platform may have some heating uh, cells over here. The heating plate may also be there. So those heating plate help it to sustain at the moderate rate of cooling. So that moderate rate of cooling provide the surface stability. So that surface stability is there. Like there is a material which is known as ABS, and other materials are also there, like polycarbonate, or you can say nylon. All those different materials are there which can get cool faster. But there is another material which is not cool faster, which is PLA. So in case of PLA, we do not need to have some heating operation over here, but in different materials like who has the faster rate of cooling, there we need to have this heating build plate, and that heating build plate can be heated up to the temperature of last transition temperature of respective material. So this is the process which is taken care at this particular system. So the basic technology remains same, like your material is extruded through this particular portion and it went to the this particular heated area. That heated area melts this particular wire from material up to melting point of that particular material. Like for PLA, it varies from 190 to 220 degrees, so it may heated it up to that particular area, and through this particular nozzle, which is relatively have the dimension according to your material diameter. So like as a standard, it would be having 0.4 mm diameter. Through that 0.4 mm diameter, it may be extruded over here and deposited accordingly. So this heated area would be having a heating cartridge and the heating sensor that senses the heat at what temperature, and that all thing can be controlled through the machine, through the controller board of the machine. And that the same thing can be addressed through the slicing software. So this is the thing about this particular technology. So we are having a video with us so that you will be able to know.
Let's take a look at the 4Ws with regard to support structures in your 3D prints. 4Ws, that's why, what, when.
So this is a large volume 3D printer which is placed over here. So this is a build platform. So as I told you, in Cartesian coordinate system, you may have a mechanism where the bed may go down, and in some mechanisms the bed may have the multiple motions, like it may have the g-axis motion as well as the y-axis motion, or you can say x-axis motion. But in this particular format of printer, as the build platform is very huge, it is a build platform is varies from 1 meter to 1.5 meter in x-axis, and 1.5 meter to 2 meter in y. So this is why this particular build platform cannot be moved up and down or to and fro, or you can say back and forth. So that is why there is a gantry system which is over here. So all the motions which are here in this particular machine will be taken care with the help of this head. So these gantries will allow to move it in x, y, and z direction. So this is just because the bed is very bulky that cannot be moved up and down. So it will take a lot of energy. It will take larger volume, larger size motors to it. Those motors may not be the stepper motor, those motors may be the servo motors. So this is why this particular arrangement has been made. So in this video you will see some clues related to the technology. You will see some actions going on with the machine.
And where? W number 1. Why? Why are support structures needed? The 3DP-1000 3D printer utilizes FFF, fused filament fabrication, which works on the additive manufacturing principle of heating and laying down material layer by layer, creating an object. Supports are needed when material must be deposited on a layer where there was not a previous layer. More complex models, which include steep overhangs or hollows. You can coordinate the by using support structures. W number 2. What? What material can be used for support structures? With a printer that has just one extruder, known as a single extruder, you will likely use the same material for supports as you use for the part you are printing. These support structures simply break away from the part after printing. If your printer has two extruders, known as a dual extruder, you have the flexibility to print support structures using different materials, such as water-soluble PVA, polyvinyl alcohol, which dissolves in cold water, making it ideal support material for complex ABS or PLA prints. W number 3. When? When are support structures needed? If your model has areas that overhang over 45 degrees, you need supports. Let's take a look at a model of a teapot. Due to the extreme angle of the overhang, this teapot would not be printable without the use of supports. W number 4. Where? Where do I need to add support structures? This is where the 3D printing software can help you. The software automatically places support structures where they are needed based on the parameters you set. Let's take a look at the Support tab in Simplify 3D. We'll click the Generate Support Material button. Then we set the infill percentage. This is how dense you want the support structures to be. Now let's set the support pillar resolution. This determines the diameter of the support structures. Sometimes it is necessary to dig a little deeper. You can manually add support structures where you think you need them, or conversely remove them where you think they aren't needed. Select the manually defined supports icon and add and remove support structures as you see fit. Once you are comfortable using support structures in your 3D prints, you will not be limited by overhangs or complex models. The sky is the limit.
So in this particular video, it was not only about the FFF technology, but it was about the support structures as well. So there are various materials which are available for the support structuring. If you are using only the single nozzle, in those cases you do not have any other option to do the support structuring. So the same material can be used as the support structure for the overhangs. So those same materials can be fitted in various parameters with the help of software. So if you are having multiple nozzles in this particular technology, in those cases you are having various options to do it. There are certain materials which can dissolve in specific solutions, or you can say which can dissolve in water. Like there is a material which is known as PVA. PVA material can be dissolved in water. So that can directly rinse away after dipping it completed component into the water. And there is another material which is known as HIPS. So that material is it can be dissolved in delaminating solution. So that delaminating solution dissolve it all. So these are the basic or you can say common support structures which we use in FDM technology. There are various materials, and some materials may allow to use some specific support structures. Some materials has some tendency to react with some different support structure, or there may be some like limitations to do that. So there are various parameters to consider in order to create the support structure. So these are some key areas which we can work on. Like this is something which addresses in order to do the research, in order to make your career, or in order to address onto the like limitations of the machine. So these are some key areas which we can address. Like there is surface finish. So surface finish is a huge market nowadays. If you look at the additive manufacturing industry, so in additive manufacturing industry, surface finish has a huge, like you can say, scope of business, because there are certain companies who can have the facility to create the 3D printing outputs, but they do not have the facility to do the post processing. Because surface finish is very important thing, because in every prototyping section, or you can say in order to check the form and fits of the components, in order to make them beautiful, it is very essential to do the surface finishing. So that surface finishing is can be considered as the business integration to the additive manufacturing. So this is a very unique thing to do. If you look at different components, those components may have the rough surface finish due to the technology usage, due to the material uses. Like some materials have the very bad characteristics in them, so they always gives you the bad surface finish. In order to address those bad surface finish, we need to do some surface finishing operations. So in various technologies, those operations may be different. Like in powder-based additive manufacturing system, you can have bead blasting system in order to do the surface finishing, or in order to remove the powder material which is adhere over the surface of the components. So these are some like things which are there in order to do the post processing. Apart from that, there is a huge market who is using the like coating of some material, painting, or some electroplating operations, you can say. So all those things to be needed. Apart from that, 70 to 80% market of additive manufacturing is based on plastic. So most of the people are doing their work with the help of plastic. But plastic do not have the conductivity. There are several materials here in the industry which are conductive, but those materials are very expensive. So, in order to make the plastic material conductive, there are some conductive coatings in the market. So, all those coatings is another market to do. Like there was one antenna which was came to us from a space agency. So they were looking for a plastic in order to reduce the weight, but they were also looking for a material which can be conductive. So we provide them the solution to put some coating which may be the conductive. So that coating works well with that particular antenna in those cases. So in the same way, you can address the different thing with the help of post-processing operations. That may be the surface finish, that may be the achieving some specific characteristics through the components. Then there is another area which is speed. So if you look at the different technologies nowadays, you may say some machines are there which can be considered as the production grade machines, which can produce the thousands of parts in a day. So those machines are there, but still it is very hard to defeat the conventional process like injection molding. Like if you look at a die takes a time of couple of weeks to generate, but once a die is with you, then you will have speed of light in order to produce the components. But if you are using this 3D printing process, then it will take a lot of time to create those lakhs of pieces. So this is one parameter where some intellectual minds can work. So speed is one barrier which is over here with the additive manufacturing process. Still, a lot of innovators are working on it. Then there is another thing which is inspection. Actually, there are no certain parameters which are there with the machine in order to do the inspection. This is just because there are not certain specific characteristics defined through the raw material. That is why there is no inspection parameters. So it is not yet defined. So in during printing inspection, which is not there available, during after the printing operations, there are only the conventional process that we are using to. So specific inspection operations are not available through the industry nowadays. So this is one area where somebody can do it. So we are already initiated something in order to do that inspection operations. We have developed a quality department. Yeah, we are also running a service bureau. So in that service bureau, we took jobs from the market, from the medical, from the, like nowadays we are working on the medical equipments. So all those medical equipments like the components of ventilator, components of oxygen concentrator, all those components we are doing. So in order to do the inspection, we are having a team with us that team inspect the component. But nowadays we are having some scanners with us. Those scanners are not that great to do. So we are planning to incorporate more scanners which are great to do the inspection operation. So this is a thing which is really is a good thing to pursue your research and career. Then there is another issue which is related to strength. So there are certain operations we do in order to increase the strength. Like recently we tried with the FDM components, we tried to coat it with the help of epoxy. But there are certain challenges. Actually, in most of the cases, it may went out through your you can say some tolerances limits. Your dimension may get off with the help of that coating. So in order to do that, there we have to work more onto the strength, or we have to find more ways to improve the strength of the additively manufactured components. Apart from that, there are certain technologies which can give you the strength of the component which are at the level of forged. If you are comparing with the metal components, forged component has the considered to be the one of the highest strength in this area. So if you are achieving that particular strength, that is pretty great. But which can be seen through certain technologies, but there is still issue with various technologies. So strength is another thing, and then you are having another issue which is related to automation. So this is one more parameter which is there. Automation is still missing with the technology because there you need to there is as there is no inspection and the feedback mechanism within the machine. So automation is also one more key area. Some machines in Europe, you can say in Germany, there are some companies who are working on the automation operations. So these things are there with their machines, but these are not very commonly available. So this thing is also open for research and for making the career. Then skill. Nowadays, India is growing, and India is having a lot of scope to do the develop the skills. So, in India itself, there are various centers like central tool rooms. You can say there are across the country. There are various central tool rooms. You can say Indo-German tool room, Indo-Danish tool room, central tool rooms, and product development tool rooms are there. All those tool rooms are having those capabilities to create the skills related to additive manufacturing and the reverse engineering, or you can say all those five pillars of your industry 4.0. So those five pillars of industry 4.0 can be getting addressed with the help of those centers. Apart from that, there are various centers which are associated with NSIC and MSME. So those different centers are also there. and some private organizations are also coming forward in order to develop the skills related to those cutting edge technologies. And the last point is cost. So there are certain people in India. There are some people in India who are developing their own machine. Like there are some moments that maybe the boycott China, and that maybe comes under the Make in India campaign. So in order to do that, there are the people who are not just importing the machine, but they are developing their own machine. But still, the challenges are there. If you are purchasing the raw material uh, from the foreign countries, then the cost will not go down. So this is another challenge. So in order to develop the raw material as well, we have to develop the facility within the country. Then we can beat this cost barrier as well. So these are some key areas which some innovator should look after related to this particular technology. So these are some career aspect design for additive manufacturing. This is a huge field. Nowadays, every young engineer is looking for this particular design for additive manufacturing thing, because nowadays whatever the software you are having with you, those softwares are based on the conventionally manufactured software. So if you are looking for additively manufactured software, there are few. So, like you may have come across with the software's name as like materialized software, which is known as Magix, and there is another software in medical which is Mimix from the same company. There are Geomagic, one of the software from the 3D systems, and there is Fusion 360 from Autodesk. So these softwares are related to design for additive manufacturing, and most of the softwares are incorporating some modules within the software in order to develop some setup related to additive manufacturing, because it is very important to set up a dedicated thing within the software which can be associated to the additive manufacturing process, because there are lot of scope to do the design changes. There are lot of scope to do the part integration, generative shapes. All those shapes cannot be created with the conventional manufacturing CAD softwares, because those CAD softwares will be having the specific geometries. There will be some circles like rectangles, circles, lines, all those things we need to use in order to develop the geometry. But we are having generative shapes as well. Those generative shapes can give us the idea where the stresses would be there, where the forces would be applied. So on the basis of that analysis, those tools can be incorporated within the software. So there are few softwares nowadays, and nowadays most of the companies like Siemens, Dassault, all those companies are coming forward in order to develop some like design for additive manufacturing software, which is also known as DFAM as a sort. So all those companies are having those skill sets. They are developing their team as well, and they are also offering the different career options for the young engineers who can pursue their career in DFAM. Then there is another career aspect which is service in additive manufacturing. So services are very common nowadays in India. If you look at different companies who are into the 3D printing, they are doing the services in additive manufacturing, because for every this situation nowadays, if you look at this particular pandemic situation, then this pandemic situation requires a lot of medical equipment that has to be supplied within a short interval of time. That cannot be done through the conventional process, because conventional process has its own limitations. In order to develop some dies, in order to develop some designs, it will have some own limitations. But with the help of additive manufacturing, there is not such barriers within that particular technology. So it may take time to produce lakhs of pieces, but it will not take time to produce some customized pieces. So that is why it is very popular thing in medical field, dental field, customized field, prosthetics field, sculpture field, aerospace field. and you can say some shipping industry as well. So it is very popular in those fields where the customization is, and not so mass production is going on. So this is very popular in that. Then there is programming for additive manufacturing. So this is another career aspect. Like nowadays, people are working on different app development. People are learning codings. So all those coding can be done for additive manufacturing. Like some people from IIT Kharagpur were developing a robot which can really work in multiple axes. Like in our all technologies which are existing today are working on the Cartesian system or the delta system. So these all technologies are having limitations. So all those technologies require some support structure. If you are building a component at a certain angle, like your component is having some overhangs, so all those overhangs can be like those problems can be sorted out with the help of a mechanism which can be a robot mechanism. So there is IIT Kharagpur is working on some robots which can print at any angle. So that will help us to create some like very critical features as well as without the support structure. So these are the things which can be developed through the programming. So those programming will be required to it, and those like that integration of hardware and the software can be done through this programming. Then there are some innovations for additive manufacturing. Like there are various innovations. Like we have discussed a lot of technologies over here, like which were based on the different materials. Like those technologies based on the different principles. Like you can say the liquid-based additive manufacturing system based on the photopolymerization chemical reaction. And then you come across the powder-based additive manufacturing. There is mostly a sintering or the binding operation. And then the third one was the solid-based additive manufacturing system, which was simply thermal process. We can melt the powder, we can melt the biform material and deposit it in the form of layers. So this is the like melting operation, simply the melting operation. So there are various materials available. There are various specific things available. Recently, in 2015, there was a company who came with an idea to develop a technology known as clip, which is basically a technology which is relevant to your stereolithography technology. There was a liquid-based additive manufacturing system which can be developed continuously in vertical direction. But the speed of that particular technology was went from if you are comparing that particular technology with SLA, was went up to 7x times of this SLA technology. So there was one concept which come across. So there are various innovations which are still unexplored. So those can be done. Those materials, those technologies, those mechanisms can be explored within the technology. Then there is another career aspect which is training on additive manufacturing. Like as there are lack of skill set, there is lack of people who are knowing about the technology. So with the help of training centers, we can develop those all centers in order to develop the skills within the people or the students or the young engineers. We can develop that in this. That industries in AM. So there are two options. Like one can pursue their startup, and another option is to join the existing one. So this is always there. So this is there since its existence. So these are all career aspects for young innovators or the engineers. So this is the thing which is related to the design for additive manufacturing. If you look at the conventional design of it, the left one was the original and the right one was the generative design. So this was a well optimized design without compromising the strength. So these are the few examples which states how design for additive manufacturing can help in order to save the time, in order to save the material, in order to save the different operations. So these are the few examples which justifies the importance of additive manufacturing, design for additive manufacturing. services can be done. This is programming for additive manufacturing, which has been explained by me. So these are some innovations like you can build a component like this. This is really important. This is related to your conformal cooling. So if you look at the dies for injection molding, those dies are having some issues related to component. There is the uneven cooling. Due to that, the warpage or some bending or distortion may happen within the components. So with the help of conformal cooling, we can provide the uh, channels within the complex shapes, and with the help of those channels, we can provide the evenly cooling through the dies. So these things can be addressed through this additive manufacturing process. So these are some industries which are related to additive manufacturing. So I have covered, I have explained much about it. So I won't spend much time on this. You can quickly go through this. These are the different industries which are there. These are the different components related to the industry. So complete transparency is also possible within the 3D printing, which is also there. So these are some different examples related to the medical. These are some food items which you can really do. Cake printing, so food can also be printed. So there is almost everything from home to the consumer durables. So moving further to the different slides, so these all things are really very common. So moving on to the further slide, I will quickly show you the another slide related to the 3D printing, and then I will move towards the reverse engineering. So we are running out of time, that is why I am moving just quickly towards this. So these are the different things which we are having with us. So there are the different sizes which we are having with us. So these are the different materials which we are working, like polymers, resins, metals, clay, concrete, conductive inks, dielectrics, bioinks. All those things can be there. So there are we can address various like industries. We can address various applications. So industries, applications, everything is there. So we are having CAD, 3D scanning, reverse engineering, STL editing software. So let me explain you one thing over here with the help of this particular diagram. So if you are having a 3D printing unit, if you want to do some research, if you want to pursue your career in 3D printing, so there are certain things. If you are going broader area, it would be the great thing, but there are certain like steps you can follow. Like you may go for designing, so you can go for CAD software, or especially for design for additive manufacturing software. That is one thing, because design is the basic thing for every technology, whether it is a conventional manufactured technology, whether it is a additively manufactured technology. So design would be always there. So design is the safest field to do, because whatever the technology would be there, design would always be there. So design for additive manufacturing would be an add-on with the additive manufacturing. After that, you are having the exported STL file. So that exported STL file cannot always have the STL file export cannot always have the right parameters, or maybe the perfect you can say perfect geometry. That may there may be some issues related to the STL file. So those issues can be addressed through one more industry. So there is another industry which is working in different ways in order to reduce those issues, in order to repair those issues. So like Materialize is a company who is playing the important role in order to do the repairing of STL, placing the STL, helping us to creating a build in such a way it will give us the efficient output, as well as it will give us the quality output. So these all things are there. So these softwares are dedicated in order to design, in order to repair, in order to give you the efficient output. So, like Materialize, there are various companies. Like Autodesk is more moving towards this because Autodesk business of that particular conventional softwares is totally gone off. So that is why they are working with the new technology. They are making their softwares friendly with design for additive manufacturing. That is why you will find all those software which are coming out nowadays from Autodesk are related to DFAM software category. So this DFAM software category is having a vast area. This cover your modification in the file STL file, because STL file editing is not the easy task and it is not possible within the conventional software. So there are some dedicated software which can do the editing of STL file format. So there are some softwares from Genesis, there are some softwares from 3D Systems, there are some softwares from Materialize. So there are the different software which works on it. So this is you can say a bridge between the CAD design software with the 3D printing slicing software. Because the 3D printing slicing software is not that strong that can repair the level of STL file. If the STL file is having minor issues in the file, those can be repaired. But if major issues are there in the file, at that level, it may get failed. So this is why your slicing software can only give you the G-code file or the sliced file out of the repaired STL file. So the repairing of STL file and modification of STL file can be done through an industry. So there is an industry in between the additive manufacturing and the design. So that industry is also there. So what are the scopes there? First scope, you can start your startup and develop your own software. Second scope, there are some industries which are working on it, and you have to understand the STL file, you have to understand the defects of it, and you have to know how to repair them. So all those things together can make you the expert of that particular thing. After that, there is another industry which is there, which is related to slicing, because slicer softwares are maybe the third party software, that may be the dedicated software. So every company who is having their product as a 3D printer, so their all softwares can be developed through the some other vendors. So they do not develop their own software. Only the parameters can be shared, only the things which are related that can be shared. The software development is a complete different process. This is another field which is there. Then next field is material. Before moving toward the system, as we have learned, gone through that particular triangle, so process parameter which can be set through those software part. Then there was system. So before moving to the system, we have to consider materials as well. So there are some vendors who are developing their materials as well. So material properties need to if a person is a mechanical engineer, but if we say he is a mechanical engineer, it won't justify his skill. We would say like he is a thermal expert, he is a material science expert, like that. We cannot say he is a mechanical engineer. It won't justify his skill. That will justify with the help of the design engineer, that with the help of like material science engineer. In the same way, if you are saying he is a additive manufacturing people, so it won't justify. So there should be something like he is related to materials, he is related to applications, he is related to the operations, he is related to the DFAM, he is related to design. What's that? So there are the different things which are associated with this particular field. So this is how it will address. So moving ahead, so this is one product which we are having. This can address all those different fields. So this is a product which is known as FormLab Form 3. So in this particular product, we are having wide range of materials according to the strength, according to the biocompatibility, according to the applications. So in this particular technology, the technology is based on stereolithography, so that is why the components would have the highest accuracy and the highest resolution. Apart from that, there are various materials which are having the various specifications. On the basis of those specifications, we can address all those industries. So these are the different 3D printers which we are having with us. So this one is the left one is a Form 3, and then the larger volume of the same segment which we are having a 3L, which is a larger size. Then we are having HP multi-jet fusion technology. Then we are having Mark Forge Mark Forge composite 3D printer, as well as MIM Adam technology metal 3D printer. So those all are there. So we are having capability to produce uh, any kind of material. Like nowadays, whatever the material is available in the world related to additive manufacturing, all those material we can go with. So every capability is with us, from ceramic to metal and from polymer to resins. All those things are there with us. So quickly moving ahead, these are some materials which we are having. So at least every material is there. So these are some machines, like this is a Markforged machine, which is a composite 3D printing machine, where you can do the carbon fiber, glass fiber, HSST fiber glass, and your Kevlar material in order to address the different applications. Like every fiber material is having the different properties, along with the onyx material, which is a composite of nylon and the carbon fiber material. So these are some applications which are currently working with the Markforged machine. Then the tooling and fixture, injection molding, making of metal sites. So quickly moving to the reverse engineering slides. So it will take more time. So that is why I am moving towards it. So here with reverse engineering, so in between, I may ask you, like if somebody is having query related to additive manufacturing, we can have a 5 minute Q&A, and at the last we can have further. Do anybody has some Q&A? Hello? Anybody? You may type your Q&A onto the chat box, and I may revert. I may take 5 minutes for this, then I will start quickly start with the.
Hello. Rajkumar sir, I have one question.
Yes, tell me.
Hello.
Yes, sir, please.
Sir, I have a question that can we measure the strength of the additives by any tensile testing machine?
Yes, we can measure.
Okay, so for that what you do means
Like there are specific samples in order to do that measurement. So we are having specific geometries. Those geometries can be printed onto the machine, and those samples can be tested.
no sir, actually how we test it? Means for the additive, we want to take their strength. So it's possible to either two material, we take different materials in where we put it, fix it, and then you
Like there are the conventional process of doing it. Okay, like you are having the tensile specimen with you for a specific material, which can be built through a specific process. So in the same way, if you are building the same geometry with the additive manufacturing process, that can be directly tested with the conventional machine or the conventional process.
sir, but it's a very tough work to making a mold or any specimen of only additives.
I am not getting your point, sir. Like how you are saying it is tough.
No, 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 sir. Actually, what I'm telling you, when we make additives, it's in the liquid form. when we make it solidify, what happen? It's a very problem to make a mold or any specimen. It should be tested in the tensile testing machine.
Why mold is need to make? We
So,
can directly get a component in our hand. That component can directly go for testing.
okay, sir.
So no need
Actually,
any kind of mold. We can directly create the component. It is like you are having a component in your hand just after, like you are giving a command to your printer, like for a printout. That printout can came out immediately. In the same way, whenever you are firing a job onto the machine, that can came out in the physical form directly, and that physical form of component can directly go onto the testing.
okay.
Like
But if you,
you are having a specimen, you are developing a component, and that component is developed on your milling machine, and once it get completed, it can go directly onto the test. In the same way you can do with the machine, this additive manufacturing component.
is such types of any testing machine?
The same machines which you are using, like for tensile testing, you are having UTM. In the same way, you are having compressive testing, you are having all those different testing machines are there. So the same machines on the relevant specimens you can do.
Actually, sir, I do one additives, own additives, biodegradable additives. So when we convert it into solidified in natural temperature, what happen in the natural temperature and pressure, they solidify it, no problem. But their solidification, what happen? Do not make a specific form.
Okay, so
Okay, sir. Later after this session, I will discuss with you. I will come.
okay, let me explain something to you. If that additive is having a specific characteristic, okay, predefined characteristic, like in the form of solid, in the form of liquid, whatever you are having, okay, like if you are having a viscous material with you, that viscous material can be converted into solid when it come into the contact of air. You are saying it. So what we are having similar characteristics in resins as well. So those resins are tried and tested with specific conditions. On the basis of those specific conditions, those parameters, like we have discussed that triangle, all those process parameters get set with the machine. Like if you are having a layer resolution of 200 micron, the intensity of laser would be required more. If you are having a layer resolution of like 20 micron, then the intensity of laser will be required less. So in the same way, all those process parameters need to expose. After exposing all those parameters, we can fill that material into the machine, and that material can get you out the desired shape. That desired shape can go out for any kind of testing. I think
Okay, sir.
I have answered your question, sir.
Yeah, thank you, sir. Thank you. Actually, what happens, sir? In my institute, there are sort of testing machine. So I want to convert in that form. In there, I am means I am facing a problem. So I have asked you.
Okay, okay, sir. So one question is from one sir. So he is asking, like, do any industry use these techniques of mass production, or these are only adopted for prototype development? So, sir, I have already explained this. There are some technologies like powder-based additive manufacturing system. These are very fast technologies, so there you can develop the component in a production way. So these are really a production machine, but uh, the speed of those production depends on your requirement. Like if your requirement is like lakhs of pieces, then it is very difficult to achieve in a limited interval of time. But if it is in the thousands, then it can be achieved in a very limited interval of time. So I am showing you one slide. If you look at this particular slide, you will find one process which is known as multi-jet fusion platform. So in this particular multi-jet fusion platform, you are having the powder form material, which is usually P812 or PA11, or nowadays we can do the PP as well, polypropylene in the form of powder. So that powder can get fused with the help of fusing agent and the detailing agent. So those fusing agent can be mixed into the powder, and with the help of the energy, this lamp, fusing lamp, those materials bind together with the help of fusing agent and this lamp heat. So after that fusion, the solidification happens. So that solidified part can be developed very fast in a very fast way, and that would be quite accurate. That can give you the accuracy up to 100 to 150 microns. And apart from that, the strength of those components would be homogeneous. So I am showing you this. This is the particular machine which can give you those outputs. And if I am having those images of, I think it get hanged. Sorry. Yeah. I think I have to stop sharing. Actually, it has get hanged. So I am connecting it again to share. So this is a particular machine which is a production machine. Here, if you look at this particular unit, this is a post processing or the pre processing unit where you can fill the build, and you can vacant the build, and you can do the post processing operations. And it will also load the materials to the build platform. So this is a complete build platform, you can say. So this is a machine where the whole process takes place. So this is a real production machine. Uh, so no any other question from your end? If no other questions, then give me 1 or 2 minutes time. I will be right back to start this reverse engineering PPT. Just give me 1 or 2 minutes time. Okay. Thanks for holding, sir. So I am just starting reverse engineering presentation. So the first thing is related to reverse engineering. What is reverse engineering? So this is a very unique concept. Initially, that was only followed by Chinese people. So this is a thing which is sometimes legal, sometimes not legal, or you can say ethical or not ethical. So let's start with some coding thing. Like if somebody has some codes and he has developed some applications. Like there are some operating systems are there. Like earlier we were having some Windows 98, 2000, like that. Earlier we were having those Windows. Then XP was there, then Windows 7, Vista, all those Windows was there. So usually the people develop those windows with the help of the old codes. Like there are some codes which are already get developed. After revisiting those codes, they can develop the further programs. So this is one thing which is related to codes. So revisiting the existing program and copying the existing code and little bit modification onto the same code can develop a new program.
हाँ जीतन सर
So this is
बताएं.
a thing which is a reverse engineering. In physical world, if you are having a
बोलिए कि
existing
चूंकि
machine,
ऑटो मोड में
existing
रिकॉर्डेड है तो
component
सबका
which
नाम
is
आ रहा है
already
वन बाय वन.
exist, if you are making a copy of that, that copy can be created and you can recreate the same with few modifications or the exact copy. So this thing is known as reverse engineering because you are revisiting the same design. Okay, but the way of revisiting is different. What is that way? Like if you are having existing component with you, that existing component can be revisited by accessing their designs which were created in order to develop that component. But if those designs are not shared by the like his developer, or which are uh, which are no more into the existence, in those cases we have to revisit the physical model in order to extract the features and the geometries. So like you must have heard those things like China is making lot of iPhone copies. China is making lot of automobile copies which are the American brands, and he is making copy of that. So all those things are existing there with China. So earlier it was only with the China, but this is the very innovative technology. That is why nowadays it has been adopted through the entire world. So what is that particular technology? They revisit the physical object, the physical data. Like somebody has developed the raw sketches of some product development. So those raw sketches can be converted into the design. You can see the soft digital model of that. Those digital model can be further processed in order to do the production, in order to do some concept design. So those concept designing, those model can be coming into the existence. Those existed component can be revisited by two ways. One way is to accessing the existing files. Another way is to accessing the existing component. So what they prefer? They prefer to go with the existing component. Once they revisit to the existing component, like you are having a old ambassador car, that old ambassador car can be revisit. Can you imagine it can be revisited through the designs? It will no, because nowadays the company who was the producer of the that particular car, that company is no more operational. So you cannot revisit onto the design, onto the portal, onto the anything, any database you cannot revisit. So you have to revisit the physical model which is already existing, which is running on the board. So you will revisit onto that. So what is the way to extract out those all features, all those design parameters, all those things? There is a technology which is known as 3D scanning. With the help of 3D scanning, you can extract all those dimensions, features, and all. Those dimensions, features can be extracted in the form of digital raster images. Those digital raster images can further converted into the vector images. If some modifications would be required, that can be done. If no modifications would be required, that can be as it is used for further operations. So that reverse engineering operation will have a dedicated reverse engineering software in order to modify or in order to copy the existing file. So that can be achieved with the help of a hardware which is known as 3D scanner, a software which is known as RE software, reverse engineering software. So after that, you can have any format of file. Like if you want to have a model in the form of STL, that would be there. If you want a model in the form of any kind of CAD software file, like .step file, IGES file, all those file formats would be available in order to do further operations. So this revisiting and creating a copy or creating a new product help us a lot in order to develop the new product. Like earlier ages, if you go into the 90s, there was only few cars which were sold in India. Like there was few Maruti 800, there was few uh, like Mahindra Wrangler and all, and there was Ambassador car. So there was few cars which were sold in India. From one company, there was only one representation or two representation which were there in the market. But nowadays, if you look at the current scenario, you will find a single segment will have three, four cars. Like if Maruti is there, is running a segment of 1000 cc car, so you will find four models of 1000 cc car from the same company. So how these things get changed? Because nowadays two things are there: the accessible to the existing design is there, accessible to the produced design is there, accessible to add-on is there. Like there are certain parameters which you need to add on to the existing system that you can do with the help of reverse engineering. Like you can scan those fitting and then you can find out some vacancies. On those vacancies you can fill the desired component. Like nowadays people are turning on to the turbo engines, so those turbo engines will require some specific like cavities within the engine cabinet, so that cavity can be find out and accordingly you can design the existing turbo. That turbo may have been used onto the certain different machine that can be placed there. So these are the different things which you can explore through this reverse engineering technology. So these are some like you can say definition you can say. So a systematic methodology to analyzing the design and existing device or system, either as an approach to study the design for redesign. So this is one definition which you can say. So you can analyze or you can do the study of the existing design. Like we do learn through those like fossils. So all those fossils give us the idea how it was developed, what was the purpose. In the same way, you can revisit onto the design. You can analyze the failure. You can analyze the best features of the component. You can adapt the best features out of it, and you can like leave those features which were the cause of failure. So you can do the adaptiveness with the existing design which was failed due to some reason, which was great success due to some reason. So you can analyze all those things with the help of this technology. So the process of duplicating an existing component, sub-assembly or product without the aid of drawings, documentation or computer model is known as reverse engineering. So this is another definition which is straightforward explaining this thing. Like you need not to access any kind of document which is there. Like if somebody is sitting there in US and is developing something here in China, if he purchases one component of it, then he can make multiple copies of that without accessing the design or drawing. That is why you will find some copies of like iPhones. You can find some copies of some great cars which are having the great values in US and Europe market. So you will find those copies here within the Asian countries. So there are some like solutions which are related to reverse engineering. So which are not exactly the solutions of actually reverse engineering is a vast umbrella. So this is one of the thing which we are doing, which is known as the product development or the redesigning of the existing component, which is associated to the mechanical engineering. That is why this is the thing which is relevant to the mechanical engineering. So these are some solutions which are related to extracting the data from the existing component. Or the same thing can be used for inspection process. Same thing can be used for doing the dimensional analysis. So all those things can be done through these particular technologies. So there is technology known as 3D scanning technology, which is a contact type and a non-contact type technology. So every non-contact type is more or less relevant to your opticals, and contact type is relevant to your probe system. So contact type is nothing but just a CMM machine where you will find a probe which will go onto the particular surface and extract the features and the cloud data, and that data can be extracted into the software, and then with the help of analysis you can get the exact dimensions of that. So in contact type, you will be able to do the precise dimensioning. You can do the inspection of that particular component which you are doing with the help of this contact type process. Then there is another thing which is known as non-contact type, where you will find the different marketed kind of thing. Like these are the different marketing terms which are available there with the scanners. So there are the different 3D scanners. One is the laser 3D scanner, then optical 3D scanners, blue light 3D scanners, white light 3D scanners. You may come across all those terms. But let me frankly explain you, these all technologies are more or less relevant to the same kind of principle. So these all technologies are based on the same principle, and these all technologies are using the same kind of light sources. Only the thing is, wherever you are using the laser, there will be the light source will be different. Wherever you are using the blue light, then the appearance of light may be the blue, but the principle remains same. So these are the different marketing terms you will come across. So, what is a process chain related to the reverse engineering? So, in process chain, what you will find, you will be having a existing object. That existing object can be converted into the scan model. So, that can be with the help of your 3D scanner, any kind of 3D scanner, whether it may be the like laser 3D scanner, it may be the modulated light 3D scanner, it may be the structured light 3D scanner, it may be the white light, it may be the blue light, whatever the term is there which is related to the 3D scanner. That 3D scanner can scan the object, and that can be converted into the point cloud data. So that scanned file is nothing but just a point cloud data. Let me explain the point cloud data. Point cloud data is the bunch of data which is extracted with the help of those opticals, or you can say the probes. Those data get collected, and that data get collected in such a way, there are millions of points on a surface which has been extracted with the help of optics. All those points have a specific position in the space. That specific position get measured, and with the help of those relative positioning among them, we extract a specific outcome of the body. So that specific gaps, specific positioning is identified with the help of the successive positioning of those points. Those successive positioning of the points will identify the exact distance of those different points among each other. So this is a specific thing we specify with the help of the 3D scanning process. Then that structured data, or you can say the point cloud data, that point cloud data can further go onto the different software which is known as reverse engineering software, in order to extract the right CAD file or the vector file. Because whatever you are extracting, that extracted data may not have the specific features, sharp features, smooth features, you can say. Those features need to that will only help you to achieve the dimensions, achieve the shapes, but that won't give you the exact geometry. So in order to get the exact geometry, you need to export that data into a specific software which is known as reverse engineering software. That there are several companies which are having the different softwares of that. So in that particular software, you can do the required extraction of geometries, and you can convert that raster file, which is typically known as raster file, into the vector file format. In such a way, you will extract the like exact vector file. Then after getting that extracted file, you can create a prototype in order to check the form and fit. Once the prototype gets successful, get the approval in order to do the production, then it can further go to the production. So this is the complete process which we follows. So these steps are there, and the steps consumption, like time consumption within the steps, will be totally dependent on your tools. Like whatever the tool is there, like your scanner is faster, then your scanning operation will take half an hour and 1 hour in order to get a scan of a particular component, or it will take 1 day or 2 days. So there is one thing which will consume your time. That will be totally dependent on the technology, on the tool, what you are using. After that, whatever the tool you are having for reverse engineering, how how you are doing it with the different tools, and what is the way of doing it, and what all different handy tools are there, how they are helping in order to develop the component. So these tools will help you to identify the time, what time it will take to complete. So this is the thing. So after that, the prototyping, again in prototyping operation as well, whatever what system you are using. Like if you are using FDM, it will take a lot of time. If you are using SLA, it will take little less time. If you are using SLS, it will take the time as a production machine is taking. So these all systems are interdependent, and those time outputs will be totally dependent on your tool selection. So this is something which is representing the point cloud data. So this is a point cloud data where are the number of points are there according to the geometry. Wherever the more point dense data is there, the geometry are having the more features, and wherever the less density, there the geometries are having the less features. So those point cloud data can directly convert it into the STL file format. So if you look at this particular duct, so this duct is having a complex STL file. So all those point cloud data get converted into a triangulation. Small triangular facets can be covered this particular geometry, and that can be directly converted into the STL file. This direct STL file can be directly used onto the additive manufacturing system, but it will be totally dependent on your requirement. Like if your sculpture application is there, biomedical application is there, then you can directly use. But if there is some applications which are related to your constraints, like mechanical engineering or automobile applications are there, with those automobile and mechanical engineering applications, you need to do some refinement, you need to get some constraints out of it, you need to get some geometrical specifications out of it. So on the basis of that, you can convert that particular file into the STL, or whatever the file format you require in order to develop the product. So these are the things. So this is a process of physical to digital. So if you look at this component, this is a wireframe design of a car. That wireframe design of a car can convert it into the digital, and you can directly print it out through the additive manufacturing system or whatever the system you are having. So this is the process of converting the physical component to digital and then physical. So in this way, you have created a copy of it. So this is an example of a vintage car. So there was a component which without this, the car was not working. So it was damaged from here. So in order to do the repairment, we did some scanning operation like this. So this scanning image was here. So with the help of scanning image, we have developed this CAD model after the refinement. So this particular file is converted into such form, and after that we have developed the component and replaced that. Then the car get into the functionality. So this is the fighter plane cabin. This is the stick which is there. So uh, this may be very expensive, it may get broken down. So if you are having one broken down stick with you, that stick can be scanned, and that scan model can be further generated in order to develop those features which has got damaged. So those features can be generated with the help of software. Then those features get further created and the new design can be developed. So that new design will be having all removed damaged pieces. So the refined geometry is there that can be directly produced with the help of additive manufacturing or any other development process. So this is an example of sculpture. So sculpture was scanned. This was the scanned geometry, and the copy of it can be developed by this method. So there is it was filled into a cuboid and converted into the different segments. So those different segments can give you the different profiles in order to do some machining operation. So these profiles were achieved, and with the help of water jet cutting, a stone was converted into this particular workpiece. So with the help of those profiles, the water jet cutting guided, and with the help of that guided water jet cutting features, we have achieved this onto the stone. So this is another example. There was a replacement of this particular speaker. So this was the interior of a Airbus, you can say. So in this particular feature, you do not have the idea what is the depth of it and what is the shape of it. So in order to do the internal scanning, you will find out the exact shape and features of it. Accordingly, you can develop your design and you can modify your speaker and you can fit that up. So this is another example of physical to digital. So here is one component that gets designed and modified, and accordingly we can develop the your thermoforming your sheets. So your thermoforming sheets will be having the impression of it. So this is how it was developed with the help of machining. So this is another example related to your customized helmets. So customized helmet can be done with the help of 3D scanning process. You can scan the head, and accordingly you can do the machining of your foam. So machining of your foam can give you the exact fitment of that particular helmet. So this is another example which is related to your physical to digital, like it was the clay model which was created. So that clay model was scanned, and after scanning it was rendered to form the digital model of a trophy. So this is one example where you can create some for Hollywood movies, or you can say some VFX. You can create some art through the you can say clay. That clay art can be rendered further in order to convert it into the digital. So after digital conversion, it can be rendered as per the required material. So it is rendered through the silver material. So it can be glow as silver. So this thing you can do through this particular technology. You can also use the scanning operation in order to uh, do the carbon dating. So carbon dating is also an important thing. So you can use scanning operation for this as well. So this is the first technology, which is a contact type technology, which is related to your scanning technologies, which we are using nowadays for doing the scanning operation. So this is a coordinate measuring machine. So in this coordinate measuring machine, you will be finding a probe which will be go through the component. So the advantage with this particular technology is that it can measure whatever the portion you are reaching. Most of the portions, if there are some depth, there are some holes are there, those holes can be measured, those positioning can be achieved. And there are certain limitations as well, like if there is very much complex shape, if the person is not so expert to extract all those complex shapes, then it is very difficult to do. So in some cases it may be impossible to extract most of the geometries. So There are some limitations as well, but the advantages over the optical systems is that it can extract the holes which are having some depth, and there are different probe knobs are there. Those probe knobs can be changed. According to those probe knobs, you can even go with the deeper holes in order to do the dimensioning. So this system is usually for the inspection purpose, not for the modeling purpose. So these are some most common, or you can say most popular technologies which are there for 3D scanning, which are basically optical processes. So conoscopic holography, laser 3D scanning, structural light, and we will discuss all those technologies one by one. And we will also discuss what are the advantages and what are the disadvantages with the technologies. So let's cover it one by one. So this is a technology which is known as conoscopic holography. So this is very simple technology where you are having a conoscopic unit, which is a holography system. Like a hologram is there, which is having the different fringes at the different angle. So on the basis of those fringes, you can analyze the depth of it. So the software itself analyzes with the help of its interference patterns. So like you are having an object placed over here, that object is having gone through with the help of light. A light source is ejecting light on the surface, and that light get extracted with the help of objective lens, conoscopic unit, and those light patterns will create interference patterns over here. With the help of those interference patterns, this will give you the feedback, or your software take feedback out of it, interference pattern. So by this feedback, it analyzes the depth, it analyzes the different distances from one object. Like this is the distance which can be analyzed with a specific fringe parameter. Then this distance will analyze with different fringe parameters. But the thing is, whatever the thing is exposed in front of the light, that can be analyzed over here with the help of fringes. Those fringes can be analyzed with the help of software. On the basis of that, that particular extraction get transported into the software which is relevant to this particular technology. So this is the process which is there for conoscopic holography. So this is not widely used, and this was the old technology. So this is not no more in a commercial way. So this is usually used by some specific applications. For this is limited up to certain group of people. So this is not very much common in use. This is a device which is there for conoscopic holography. Then there is a laser 3D scanning process. So in laser 3D scanning process, you are having a working principle which will be common for all different technologies which are there in optics. So in this particular technology, you are having a working principle of triangulation. So in this particular technology, if an object is extracting a data from the object, uh, the machine is extracting data from the object. That particular object has a millions of points on the surface. Like that can be vary on the basis of your resolution, whatever the resolution you want in it. Like if you are extracting an image, you are having a capability of 60 megapixel, but you want to do it at 12 megapixel, then you can get the same image. So accuracy won't be affected, but the detailing will affect. So if you will doing some zooming operation onto that image, it will have less details, but the accuracy of those points won't be affected. So in the same way, in this particular technology, if you are having plain walls and not so featured object, that feature can be expected by low resolution. And if you are having a featured geometry like jewelry applications are there, so all those jewelry applications uh, can be done at a very high resolution, so that every fine detail can be extracted. In the same way, this will work. So the principle remains same. So there are the different millions of points. The light source like projected onto the surface of the object. On that surface, number of points are there. All those number points has some reflection parameters. Those reflections goes back to the camera, which is typically known as a receiver. After extracting those features from the reflected image, there is an angle between the source and the extractor. Those source and extractor angle can be calculated the depth of that particular point. So this is the basic principle which will be applicable throughout the optical process. So this is a basic triangulation principle. Every different point will have the every different angle on the basis of that angle, because every distance which has been set with the machine is predefined. Like the distance from the transmitter and the receiver, like the projector and the camera, is like predefined. So if it is reflecting back from a particular point with the help of triangulation method, it is very easy to calculate by the machine or the software what is the distances between the two different points which are there. And there are a number of points, so it is very fast process to analyze all those gaps and extract the geometry. On the other hand, there is one more thing which will be working with along with this triangulation method. There is no intellectual brain within the software as well as with the machine. That is why it has to be identified a base. Like in CNC machine, we have to give a zero position every before starting every job. So in the same way, we have to identify a specific geometry. On the basis of that reference, we have to start the scanning, and every scanning operation will have some previous predefined extracted geometries, so that it may analyze very fast and it may analyze it correctly, so that it will find the similar geometries in the previous scans, and it will accordingly join all those scans together and align together and give you the globally aligned data. So this is very important in this thing. So this principle works throughout together, but the difference would remain like here in this particular technology, you will be having a laser uh, light sources, and the camera will extract all those lights. So this technology is relevantly very slow because laser light extraction is very slow operation. So this is the laser technology where you can find this UV laser is there. Those strips are there which will be impacting onto the component, and after this there is a these are the cameras which will be receiving all those different points. On the basis of this triangulation process, this will extract the data. Then there is a structured light. So structured light will be having a projector here instead of laser. So that structured light may be a white light source, you may say. So white light source, as the principle remains same, the angle will be there, the triangulation will be there. On the basis of that angle, it will analyze the distances between the different points. But the thing here is the projected method is much faster than the laser process, because laser process has the stripes in that, but the projector has the complete surfaces of light. So that complete surface of light reflects back the areas. But there is a little limitation in this particular process. We cannot do the dark object with the structured light scanning operation, because dark objects do not have the reflections in it. Apart from that, in 3D scanning operations, you cannot do the depths, the holes, or you can say in other words, whatever the things which are disappeared from the light, that cannot be done. Apart from that, in laser, you would be able to capture the colors as well. But here you need to place some extra equipment in order to extract the colors. So in laser, you need not to do that particular thing. And this is faster, but the dark object cannot be scanned. But in laser, you can do some specific settings within the software. So on the basis of those settings, it can do the neutral, it can do the light, it can do the dark objects as well. Apart from that, in every technology, you won't be able to do the complete reflective surface as well as the complete transparent surfaces. Like a glass cannot be scanned through this because light may transmit from that, and a complete reflection won't give you the right results, as the light, wherever the complete reflection is there, light itself cancels it out while it is receiving through the camera. So that is why the complete reflective surface cannot be scanned, and the transparent surface cannot be scanned. So this is a structured light source, which is typically a white light. So there is a modulated light thing. So in modulated light, there is a modulator which is there, which increase the intensity of light, where it is a white light source, where it is a laser light source. So it is typically used for those applications where you have to scan a huge building, a huge area, or even if you are going to scan the mountains, or you can say a complete city, you can say. So wherever your requirement of scanning is huge, in those cases you can use this thing. So this will having a modulated light source that can go for a wider range. So that is why, and the rest of the principle remains same. So this is the modulated light source, which is typically used for doing the construction works, as well as to get some GIS work as well. Then there is another technology which is known as volumetric technology, which is quite similar to your CT scan process. So there are different intensities in this particular technology. The advantages are there that you can get the internal features as well. Like in different technologies, you won't be able to get the internal features. You can get only the surface features. But in this particular technology, you are having advantage to get the internal features, the cross sections from the inside. So this technology is very simple. This works on the layer by layer mechanism. So you are having the different set of intensities at the different layer heights. On the basis of different layer heights, you can extract the data, and you can combine those all data together to form the 3D file. So in this particular technology, you can compare it with the CT scanning operation. Like CT scanning is having a bone, or you can say skull scanning at the different angles and the different heights, or you can say lengths. So those different heights and lengths combined together to form the digital model. In the same way, this technology will work. So this is something which is related to your volumetric scanning. So internal features are very important. In case internal features are important, then you can go with this particular technology. Then there is another technology which is known as photogrammetric technique, where you have to get number of images of the object from different angles, and with the help of a software, you can combine them together. So there are two ways of doing it. One, either you can have the multiple cameras with you, you can place for the single click, or you can have a single camera and object can be placed at the different angles. More the pictures you will be having, the more detailings will be have. So in this particular image, you can find a person is taking capturing the object at the different angle, or you can say the different positions. So from those different positions, you will be extracting the different images of it. Those all different images can be taken out into the software. In the software, it may get processed to form the 3D model. You will find another image to show you the another way of doing it. So you can have the multiple cameras, you can have thousands of DSLR placed over here, and with a single shot you can get the images of at different angle of the same object. Then that particular set of image can be sent onto the software for the processing and the rendering. After that processing and the rendering, you will get the fine data out of it. So this technology is considered to be most detailed technology, because here you will find the every bit detail out of it. But no any technology is perfect in 3D scanning. So there are some refinement requirement with the database which we achieve from the different technologies. So those refinement can be done through the software. All those tools would be available with the dedicated software, as well as there are certain third-party softwares are there which are very handy to refine all those databases. So a, along with all those different technologies, this is the most expensive technology, and this is the most accurate technology you can say. And all those different technologies are specifically for different like you can say applications, and on the basis of the prices and on the basis of applications you can define that. So most of the most used technology is structured light technology, which is faster, which is cost economical, and which can solve all your purposes, which are general purposes related to the current industries. And this technology, photogrammetric technology, is usually for creating the like some wax statues, some sculpture designing, some like gaming clones, and some digital you can say paintings and something. So all those things can be done through this digital 3D painting, digital 3D models. All those things can be done through photogrammetric technique. So there are some like you can say some features related to some laser scanning technology, some process parameters. Like first of all, we have to do the scanning. Then scanning can happen over here with the software. The positioning of the object can be done, and that on the basis of that positioning, you can extract the data. Then this data will be looks like this, and then further that data can also have the color texture within it, and then that particular data can be exported directly into the STL that can be transported into the different CAD softwares in order to do the further refinement. And after the refinement, after the importing the data, you will find it into a particular reverse engineering software, which is typically known as RapidWorks, which is one of the reverse engineering software. And then after that you can refine the data and you can get the vector file out of it. So this is the vector file out of that particular data. So you can see the differences of it. So here you won't find any feature, detailed feature of that particular receiver, but here you will find detailed receiver features. You will find all those details in a vector form. So this is another way of doing it. So here the particular image is directly converted into the auto surfacing feature. So this will also work for various cases. If your object is not to be converted into the vector file, so you can convert that into the quadrilateral form. So this is a quad form geometry, you can say. So there are various applications which we have explained to you during the different thing. So you can go through this quickly. So these are the different applications again. So here I am done with my presentation related to reverse engineering. So I welcome the Q&A from your end, sir. If anybody has any question, then I am open for answering it. I would be very happy to answer all your questions. Hello? Hello?
Yes, Chaitan sir, please continue.
Participants are allowed to ask their queries to Engineer Rajkumar, if any. Okay, it is my pleasure to propose the vote of thanks to Engineer Rajkumar to deliver such a nice and informative talk on CD and reverse engineering. In this today, he has covered almost all the topic of these two emerging technologies, which are very useful for engineers and academicians. He not only provided the theoretical background of these processes, but also used videos to provide the practical exposure of the principle of these two processes. I, on behalf of entire organizing committee of this FDP, would like to thank Engineer Rajkumar to spare his valuable time with us. I hope we all will learn a lot from Engineer Rajkumar about 3D printing and reverse engineering. I would again thank all participants to have attend tomorrow's session also. Your strength motivate us to organize such FDPs, as well as it also motivate the speaker to deliver more from his lecture. Once again, with thanks to Engineer Rajkumar for delivering this wonderful lecture to the audience of this FDP. Thank you, Rajkumar sir, to spare your time with us.
My pleasure, sir.
Over to Chandan Kumar sir.
Thank you, Chetan sir. Thank you, Rajkumar. It's a really very elaborated presentation. And thanks to all the participants and looking forward to meet tomorrow. The talk will be delivered by Engineer Vyom Ranjan on drone technology. So I am very much confident and assure you that tomorrow's talk will be also very interesting and informative.